Hello friends, this video on aldehyde ketones carboxylic acid part 22 is brought to you by examfear.com. No more fear from exam. So the question is, how will we convert ethanol to butane 1,3-diol, butenol and butanoic acid? Let's take one by one. So let's convert ethanol, that is CH3COOH, to butane with probutane 1,3-diol, 1,2,3-diol. Let's convert this. So we see it has 2 carbons, it has 4 carbons. Correct? So we have to go for some condensation. It has alpha carbon, alpha hydrogen. We can go for aldol condensation. To go for aldol condensation, what you do? First step you have to do is you have to react with base. So base will do what? Base will attack this alpha hydrogen. This becomes CH2 minus COH. You take 2 of these, and now this will react with the other, this one, and now this is slightly negative, slightly positive, so it will attack here. So with this, what you get is CH3CO minus H, and here you get CH2COH, and this O minus will get hydrogen from somewhere. So what it will get is what we are looking for: CH3COH with the H here, CH2 and COOH. This is what we'll get, but we are looking for 1,3-diol. This is aldehyde, right? We are looking for alcohol, so I can do a reduction. I can do a reduction using LiAlH4 or NaBH4, any of the reducing agent I can use. So this aldehydes will become alcohol. So what I'll get finally, CH3COH, H, CH2, CH2OH, right? Or I can also use this zinc amalgam. Yeah, that will also give me, you can do hydrogenation with that. Correct? So I did the aldol condensation, I got alcohol, and this was aldehyde part. I did the reduction, and with that I got alcohol. The next is ethanol to butenol. So I have my ethanol. I have to convert this into butenol, meth eth probutol 1 2. At 2 I have an ene. Yeah, this is the compound I have to convert. So again, since it has 2, it has 4. We can do aldol first. Let's do aldol. So I'll do aldol. OH minus will attack this, becomes CH2 with a minus, CO and H. Again we have, since I have used 2 of these, CH3, COH, slightly negative, slightly positive. This will attack here. So what I get is, and this will get some hydrogen somewhere. I'll do everything in one stop. So I get CH3, CO, and I'll get H here, and here I get CH2, COH. This is what I'll get, right? But I'm looking for butenol. That means if I can just remove what I can just form a double bond here actually, right? I can remove this OH and H, I'll get double bond here. So to do that, I've just heated. When you heat it, it removes the water from here. Correct? Obviously in the presence of acid. So what happens is this H plus will again come and attack this guy. This will become H2O plus with a positive charge here, and this has to get rid of positive charge. What it will do is ask this hydrogen to kick off, it will form a double bond. So it will form CH3, CH2, sorry, CH, COH and H, and this is what you will get. Just heat it, the water will go off. correct? The next is again the ethanol to butyenoic acid. See, I have got since but to enol. What I can do is in this I can use any reagent, tolerant reagent, let's suppose, or filling, right? Tolerant reagent. So it will convert this aldehyde to acid. Till this point the steps will be same, right? For this, from here just use the oxidizing agent and that will convert this into my butanoic acid. So if you want, I can write the formula of this. Same thing. Here will be COH. That's all. This is butyenoic acid. So here we have to write the structural formulas and name all 4 possible aldol condensation from the propanal and butanol. So let's see what is propanal. Propanal is meth-eth-propanal and butanol meth-eth-probutanol. Here we see both of these has alpha hydrogens, right? This has alpha hydrogen and this also has alpha hydrogen. Since both of these are alpha hydrogen, we will get 4 products. So let's see the reaction mechanism. First case, let's assume that the nucleophile attacks this propanal, this one. So what you get here is, if the OH minus attacks this and take out this hydrogen, what you get is CH3, C minus, COH with H1. And the next scenario is the base attacks this hydrogen. So what you get here is CH3, CH2, CH minus, COOH. Correct? 2 scenarios. Now what can happen is, in first scenario this can react with propanal, that is this guy, or this can react with butanol, that is this guy. Here also this can react with propanal, this guy, or butanol. Correct? 4 possible options. So let's see what happens here. If it reacts with this guy, propanal, what will happen is negative charge, somewhere it will get H plus, attack, and this will attack this. Let me change the color. Yeah, so this will attack this carbon. So what you get here is 1, 2, 3 OH. Here you get, well, let me put H here actually. Let me put H here, and here you get C with the H with the CH3 and COH. This is what you get. In this case, this will react with this and this will get some H plus somewhere from the system. So what you get here is 1, 2, 3, 4 carbon. This will become OH, correct? And now in this will get attached. Similar to this, right? C with the H with the CH3 and with COH. Similarly here, it will go like this, minus, it will grab some H plus from the system, and this will attack here. So let's see, 1, 2, 3 carbon. So it will be 1, 2, 3 carbon, this with the OH bond and 1 H here, and this part will be this whole thing. There is a C here with the hydrogen, put a hydrogen here, with COH, put COH here, and this part is what? C2H5. C2H5. Similarly this one, 1, 2, 3, 4 carbon, 1, 2, 3, 4 carbon, right? This will become this is a minus, it will attack some H plus, and this will attack here. This becomes OH, and this is hydrogen here. Now this carbon is this carbon, right? Now this whole thing will be attached here. So the new carbon is this one. It has one hydrogen. It has one C2H5. It also has this COH. So if you see, these are the 4 compounds we should be getting. You can add extra hydrogens which I have not shown just for simplicity. You can add those if you want. Correct? If you just try, it's very simple actually. The only thing you do is first attack the base will attack and eat the alpha hydrogen, because the aldol condensation is all about alpha hydrogen, and then you get this carbonyl, and this carbonyl will attack this carbonyl group. That's all. The organic compound with molecular formula C9H10O forms 2,4-DNP derivative. That means it is either aldehyde or ketone, right? So this is DNP, means either we have the information now aldehyde or ketone. First information. Reduces tolerance reagent. That means it is aldehyde, not a ketone. Correct? Undergoes Cannizzaro reaction. Cannizzaro reaction means it doesn't have alpha hydrogen. So no alpha hydrogen. So it's aldehyde with no alpha hydrogen. On vigorous oxidation, it gives benzene dicarboxylic acid. So let's first draw benzene dicarboxylic acid. So with that we'll get some idea. 1,2, right? 1,2 dicarboxylic acid. This is what the compound gives on vigorous oxidation. And the compound is not having any alpha hydrogen. And this is C9H10O. So that means it has a benzene ring. So C9H10O. Remove this C6H5. Let's see what you get. You get C3H5O. So let's first draw a benzene ring. That means there's a benzene ring for sure. And there is something here, there is something here. Correct? Because on oxidation it is giving 1, 2. So, and C3H5O is remaining. And it is an aldehyde. Correct? With no alpha hydrogen. So that means this is the one. Because this is the aldehyde with no alpha hydrogen. If you say CH2COH, that means it will have alpha hydrogen. It says no alpha hydrogen and aldehyde. So this is a possible scenario. So from this you multiply COH, what you get? C2H. C2H4 you get, right? C5H10, C6H5, C2H4. C2H4, if you add one C2H4 here, if you replace H with C2H5, that is you are adding C2H4, right? Then you get this compound. Why I am adding C2H5? Because there was the H here. I replaced H with C2H4. So total, if you see now this compound, formula is C9H10O. There is one oxygen. There is 1, 2, 6 plus 7 plus 2, 9 carbon. And if you see hydrogen, 1, 2, 3, 4, right? 5 and 5, 10. So this is the formula of this compound. Looks good. So we have to identify the compound. The compound is this. If you want, we can give the reactions also. All the reactions. That is not required. If you want, I can give. This is already given benzene dicarboxylic acid. For toluenes, it will become again a carboxylic acid. So this will become CO minus, and C2H5 will be untouched. That is what will happen. And some silver will be precipitated out. When you react with 2,4-DNP derivative, what you get is, we have seen this reaction so many times, this O and H2 from N will combine to form a double bond. This one. it will form something like this, NO2, and this will be NO2, and some water will come out. These reactions are not required, just extra I have given, but just understand that with these information you could easily identify that this is my compound. Correct? Let's take another example. So we have to arrange this following compounds in increasing order of their reactivity towards HCN. CN minus is a nucleophile. So we have to see which one is more reactive towards nucleophile. We have seen this. There are two effects: steric hindrance effect and the plus I effect. Let's first draw the picture of this. Acetaldehyde is this. Acetone is this. Di-tert butyl ketone, CH3C, this tert butyl, di-tert butyl ketone, right? So both sides. And then methyl tert butyl ketone. So I have this tert butyl one side, I have methyl one side. Now if you see steric hindrance, the maximum here, this is worst. This is number 4 I'll give just now, straight away. Right? And if you see, these two are aldehydes. So these are top two. This is also ketone actually. We compare these two also, right? This is the only aldehyde here, right? So I'll give number 1. So 1 and 4 is done for me. 1 and 4 is done. Only aldehyde, number 1, most reactive. And this is the one with the ketone, all bulky, no space, steric hindrance. This is the worst. Now out of these two, if you see, you can say that this has more steric hindrance. Directly you can see. This is less steric hindrance. So this is better. This will be number 2 and this will be number 3. This is my order of reactivity. So acetaldehyde is number 1. Then I have acetone, and then I have methyl tert butyl ketone, and then I have di-tert butyl ketone. So the question says we have to give the chemical test to differentiate between propanal and propanone. So if you see, this is aldehyde and this is ketone. So aldehyde and ketone, we know we can use Tollens reagent. Tollens reagent. So Tollens reagent will be helpful to distinguish between propanone and propanol. So Tollens reagent will reduce aldehyde but will not reduce ketone. If you want, I can give you the reactions also. Propanal. So it is methitprop. This will be the propanal, and if it reacts with my Tollens reagent, this is my Tollens reagent, some basic medium, what you get is CCCOO minus. This is what you get, and silver will come out. This will give you confirmation it is a aldehyde, not a ketone. The next is we have to distinguish between acetophenone and benzophenone. So let's see, acetophenone is what? This is my acetophenone, and benzophenone is this. So if you see, what I can do is I have a lot of options. This is the methyl ketone. I can use what? I can use iodoform test for methyl ketone. So iodoform test here, it will pass this, it will not pass because it needs a methyl group. So for example, I have phenyl, I have this with CH3. If I do iodoform test, I know I, this sodium hypoiodide, what I get is my phenyl with CO minus or CONA, but I'll get CHI3, and this is my yellow color iodoform. Right, with that I can say that, and I'll get sodium hydroxide also. So with this I can say that it is acetophenone. See, for this test as I told aldehyde and ketone, we have other methods also. I can use Fehling test also. Right? Fehling test also will work with aldehyde, but will not work with ketone. Correct? So both these we can use. And if you see the propanol and propanal, propanol. So if you see, propanol is a methyl ketone actually, right? And propanol is not a methyl ketone, it's aldehyde. So we can also use here iodoform test. The told iodoform test is for methyl ketone. So I can also use, so in this case I can use iodoform test, I can use Fehling test, and I can use normal toluene test also. Any of these three can be used here. Correct? So if I use, let's suppose iodoform test, so what will happen is I have this guy, right? So it will react with NaOI, so it will form CH3 COONA plus it will form CHI3, and that is yellow in color. Correct? And if I use Fehling test, what we'll get is cuprous oxide, that is red brown PPT, red brown precipitate. So we can use three methods to distinguish between propanol and propanone. Let's see how can we distinguish pen 2 on and pen 3 on. Meth, eth, pro, but, pent. Meth, eth, pro, but, pent. So this is pen 2 on and this is pen 3 on. So if you see, both are ketone, but this is methyl ketone. This is non-methyl ketone, right? So we can use iodoform test. If you want, I can give the reaction. React with NaOI, it will give you Na plus CHI3. And this is yellow in color. So with this you can make out the difference. This one will not give the yellow PVT. No yellow precipitate. Let's see, benzaldehyde and acetophenone. So this is my benzaldehyde, acetophenone. See, the first thing is, this is aldehyde, this is ketone, so you can use Fehling test, right? So you can use toluene test. See, as I told you, the Fehling test won't react with aromatic aldehydes, so this will not happen. So this you can use toluene test, you can't use Fehling test. Fehling test will not happen for both of these. Please keep in mind, Fehling test will not work for these things. Only toluene test will work, because Fehling test will not work for aromatic aldehydes. Now acetophenone. Now if you see, one more difference between these two are, this is methyl ketone, this is non-methyl ketone, right? This is not a ketone, but this is a methyl ketone. So you can also use iodoform test. Correct? Since there are two different compounds, aldehyde and ketone, you can use toluene test, but you can't use Fehling test here because it's aromatic aldehyde. And you can use iodoform test also. Why? Because one of these is a methyl ketone. I'll not give reactions for this now. Now methanol and ethanol. So this is my methanol and ethanol. So now if you see, this you can use, actually it has CH3CO, it doesn't have CH3CO, both are aldehyde, so you can use iodoform test. You can't use Fehling test or toluene test because both are aldehyde, but one has CH3CO, one doesn't have CH3CO, other has C2H5CO. In this you can use iodoform test. So if you use CH3COH with NaOI, what you get is SCOONA, SCONA and CHI3 plus NaOH, and this is yellow. Correct? Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.